In this video, I want to look at two special right triangles and the ratios of their sides. And so I'm going to construct an understanding of these. Let's take an equilateral triangle, and our angles we know are 60 degrees in an equilateral triangle, and we know that the lengths of the sides are equal. So what I'm going to do is I'm going to take the lengths of the sides to be, let's say, 2 centimeters, 2 centimeters, and 2 centimeters. These are all the same. Now, I'm going to bisect the angle up here, which means this is 30 degrees. And when I do that, and I drop a segment from there, bisecting 60 degrees, it will make it 90 degrees at the bottom, and it will bisect the side down here, because it's equilateral. There's symmetry. And so this length here is 1 centimeter. And what I'm going to do now is I'm just going to narrow in on this particular right triangle. So let me just redraw it over here. I have this being 2 centimeters. This is 90 degrees, 60 degrees, 30 degrees. This is a length of 1 centimeter. And if I do Pythagoras to calculate this side, my question mark here would be that question mark squared would be 2 squared minus 1 squared, which is 3. So the missing side is the square root of 3. And so the length of this side of the triangle is root 3. So what this is saying is that in any 30 degree, 60 degree, 90 degree triangle, the ratio of the sides will be 1, 2, and root 3. And it doesn't really matter if we make the triangle bigger or smaller. If we keep the angles as they are, the sides will stay in proportion to one another. So the ratio is 1, 2, and root 3. But if I were to make the triangle bigger, and that was 2, this would be doubled, this would be 4, and this would be doubled to root 3. So you need to know this triangle and the ratios of the sides in a 30, 60, 90 triangle. The other triangle you need to know about is a 45, 45, 90 degree triangle. Okay, so what do we know about such a triangle already? We know because the two angles are the same that it's isosceles, so these two lengths would be the same. Let's just assume that they're 1 unit in length, 1 and 1. And then by Pythagoras we could calculate the length of this side. The question mark squared would be 1 squared plus 1 squared, which is 2, so the missing side is the square root of 2. Alright, so what we're saying is that in any 45, 45, 90 degree triangle, the ratio of the sides is 1, 1, and root 2. If this triangle was triple in size and it was a 45, 45, 90, this would be 3, this would be 3, and this would be 3 times the square root of 2. Okay, second triangle whose ratios you need to know. Alright, one basic application of the special ratios in triangles. Let's suppose we have an angle of elevation from a point on the ground. Okay, so we need some ground. There we go. And from a point P to the top of a tree, so let's say our tree is here, the angle of elevation, which is the angle looking up, you'll remember, is 30 degrees. If the distance from the point P to the base of the tree is 14 meters, what is the exact height of the tree? Now you want to clue into this word exact. Whenever you see or hear the word exact, it means that we want an exact value. We don't want decimals that have been rounded off. And remember that the decimals that are problematic are irrational numbers, because irrational numbers go on forever without a pattern. It's impossible to write an irrational number as a decimal and have it exact. So what we're going to do here is we're going to set up a ratio. We can see that this is a 90, 30, and so we know this angle would be 60 degrees. If we think back to our basic 30, 60, 90 triangle that we just talked about, the ratio of the sides was 1, 2, and root 3. Just put the numbers in order here. The smallest side is across from the smallest angle, so this is 1. The largest side is 2, which is across from the 90. And then the root 3 is the other one. That's how I remember the order of the ratios. And these two triangles are similar. They have the same angles, which means sides are in proportion. So we could say that x is to 1 as 14 is to root 3. And so therefore x is 14 divided by root 3. And we don't want to make the root 3 into a decimal because we can't have a irrational number written as decimal form and have it exact, so we're going to have to leave it as it is. The only other thing I'm going to do here is it's typical to not leave a radical in the denominator. So what we're going to do is to get rid of that, I'm going to multiply top and bottom of this expression by square root of 3. I can do that because square root of 3 over square root of 3 is just 1. So if I take this and multiply by 1, the thing I get in the end is the same. So 14 times root 3 is 14 root 3, and root 3 times root 3 is root 9, or 3. So 14 root 3 divided by 3 meters is the exact length of this tree.